some sort of pattern, and as we talk about this, we're going to see what are the big patterns that we're noticing when we pick certain groups of elements from the periodic table. Let's have Alondra, Jessica, and Derica. If you will start, somebody explain to us a little bit about what the elements were that you had and what was the pattern that you noticed.
We noticed that they're all in the same group, which is group 2.
That's it. All in the same group. Anybody else notice that all of theirs were in the same group?
Yes,
Yes, quite a few people noticed that.
Yeah, when they were in our group, that three of them.
All in the same group. So you had beryllium. What was one of the other elements that you had?
We had magnesium
Okay.
and calcium.
Okay, so beryllium, magnesium, calcium, all in group 2. If we were trying to find them on the periodic table, knowing that they were in group 2, would we be able to find them pretty quickly?
Yes.
You're right. Okay, as we go through that, we'll probably come back there and see if there's anything that we want to add to that particular pattern. Let's look at Faith, your group. Tell us about what you found.
We noticed that for our group number it was the same, and then for the period number it increased by 1. Like it kept going down.
What, as a group, what do we think is the most important of those two patterns? That they're all in the same group, or that the period number increased? The period number increased? Could I have could I put it differently on the worksheet where it was selenium, sulfur, oxygen, tellurium?
Yeah.
Would the period number increase if I did that? No, but would the group number still be the same on all of them?
Yes.
So what's probably the more important pattern there? The group number is probably the more important pattern. Is there anything significant about group numbers?
Yes.
Probably so. Let's why don't you guys tell us about yours and see if you can shed some light on what's significant about a group number.
On the outer shell, they have the same number of electrons that they do in the same. They're in the same group number, and that group number shows that they have the same amount of electrons on the outer shell.
What group number did you have?
7.
7. Denise, are there 7 electrons in the outer shell there? Give her time to count them. It's okay. We're all gonna be here till the time to go to the next class, right? It takes her a couple more seconds. It's okay. So they have group number 7, and there happen to be 7 electrons in that outer shell. What group number did you guys have? 2. How many electrons did you have in the outer shell? 2. Let's hear from you.
Our group found the pattern that they're both in the same group, which is 1, and they're they're both in the same group, and what we found is the last structure was 1.
One what? Which type of particle? 1 electron. So again, group number, what was their group number?
1.
1. How many electrons in that last shell?
1.
Alright, so what we noticed is that, what you guys all noticed, that the similarity is that they had the same amount of electrons and the farthest shell or ring. Okay, the group tells us how many electrons are on the farthest shell, and on the periods.
The periods tells us how many rings it has.
Okay, what's your evidence for that?
That carbon was on period 2, and then I don't know what this one is, but it was on period 3.
Okay. Okay, so they're even adding a little bit maybe to this idea. So again, we're noticing among the patterns, we're noticing this idea that outer shell has the same number of electrons as the group number that it's in. but they've added something about maybe there's a pattern with the period as well. We're gonna come back to that pattern in a second, but let's, before we do that, come over here with Karen, Jonathan, and Janet.
We noticed that they're all in the same group number, which is 0.
Okay. Now, here's where it gets tricky. Do you have 0 electrons in the outer shell? No. Everybody take a moment to look here, though. What is significant about the outer shell? On the two, they've drawn helium and neon, but even if we were to look at the other elements that they had, what's significant in that outer shell?
It's different.
There's something different about it, right? So neon, it has a proton number of 10. So if I was to move to the next element that had with the next amount of protons, if I was to move to something with 11 protons and it was still neutral, what would I have to also add? 11 protons, if it's neutral, how many electrons is it going to have? 11, right? Where would I put that 11th electron?
On its own ring.
Why on its own ring? The outer ring is full? How do we know the outer ring is full? It has 8. And what have we said the limit would be on that second ring? 8. What would the limit of electrons be on the third ring? 8. Okay, but let's look at that helium. Helium doesn't have 8 electrons in that entire house. Is it full? Why is it full, Luis? The first ring can only have 2 electrons. So the pattern in group 0 is not that there's 0 electrons in the outer shell, but what is the pattern here? That it's full. Okay? So in the groups, when we look at groups 1 through 7, those numbers tell us something about how many electrons we're going to be, but also group 0 tells us that that outer ring is going to be what? Full. Now let's look at the other pattern that we want to find. Okay, so Josh, Anthony, and Shirley, tell us about your.
This one pattern that we found is that they have the same period number. The second pattern that we found is that they all have 2 shells, which is correct.
Okay, so period number 2, and at least with the 4 elements they had 2 shells. Let's look over here with Vivica.
Well, all our group numbers were even, and our period numbers were all 3, and the number of protons went from least to greatest.
Okay, number of protons went from least. Could we, again, just like we had said with one of the other groups that's presenting, could I have changed the order?
Yeah.
And then they wouldn't necessarily go from least to greatest. So while that is a pattern, that might not be the most important pattern. So what's the most important pattern here? Not the group number, but the period number is number 3. How many, and you don't have it up there, but if you look back on your worksheet, how many shells did each of those? 3 shells. So what does the period number tell us? How many shells? And in a minute we'll probably talk about one way that there's some exceptions to that, but with the level of where we're going to work with it, we won't really run into that exception very often. Okay, what I want you to do is clean up your whiteboards, put them in the back.